the equation of a circle is this. You should be able to extract the radius and the center from this given equation. So we discussed that to find the center, you divide this with -2 and you divide this with -2. So -4 divided by -2 would be 2. And 6 divided by -2 would be -3. That is the center. And for the radius, the formula is that you square both these coordinates that you just got, 2 square plus -3 whole squared is still 3 squared minus the constant in the question. The constant is not -77. So minus 77. This comes out to be square root of 90. Okay, that's the radius. Now, the question says, find the x coordinates of points A and B where the circle intersects the x-axis. Okay, let's say the x-axis is here. So then they're asking for this point and this point and their x values. So this will be some x comma 0 since it's on the x-axis. And on the x-axis, y is always 0. And B is also going to have some x value, comma 0. Okay. Now, to find these A and B x values, we need to first write down the equation of the circle and then substitute y is equals to 0 in it. So the equation of the circle would be x minus 2 whole squared plus y plus 3 whole squared equals to radius squared, which is 90. Okay. Now let's make or substitute 0 in place of y. So we get 3 squared equals 90. This gives us x minus 2 whole squared plus 9 equals 90. Now please don't start applying the identity a minus b whole square. It's already in completed square form. So we're going to take 9 to the other side. We get an 81. We will take square root on both sides. We'll get plus minus 9 over here and x minus 2 on the other side. And then we get an 11 and we get a minus 7. So that means this value here is -7 and that value is 11. So the x coordinates are -7 and 11. Find the point of intersection of the tangent to the circle at A and B. Okay, so find the point of intersection of the tangents to the circle at A and B. So let's draw a tangent at A and a tangent at B. It's not a very symmetrical one. Let me try again. So somewhere over here. Okay. Now, you also know a circle property from O levels that these two lengths are equal. Tangents from originating from the same points are equal in length. So then this length and this length is equal. This makes it a very symmetrical setup again. So this value of x will also be the value of x here at the point of intersection of the tangents. Let me call that t. So then this t is going to be 2 comma some y. Now we need to find the value of y. So what we can do is find equation of one of these tangents. Let's say I'm going to find equation of this tangent. And then I'm going to substitute x is equals to 2 in it and I'll get y. Now, how do we find equation of the tangent? Again, go back to O-level circle property, radius and tangent are perpendicular to each other. So radius and tangent are perpendicular. So let's find the gradient of A. Let's call this O. Y2 minus y1 over x2 minus x1. 3 upon -9. So -1 over 3. So the perpendicular gradient of AT is going to be 3. So the equation of the line AT would be y equals mx plus c. To find c, you need to substitute -7, 0. So 0 equals 3 times -7 plus 3. That gives us c equals 21. So y is equals to 3x plus 21 is the equation of this line. Now, when you substitute uh, x equals 2 in it, you'll get the y coordinate. Y is equals to 3 times 2 plus 21. That gives us 27. So the coordinates of that point would be 2, 27, where the two tangents meet.